My name is Josh Mode, and I'm a technical solution provider here at CARIS. And with me, I have my colleague from down under, Daniel Crummell, from the CARIS Asia Pacific office. Let me kind of go over a little bit of the background. Well, HIPS and SIPS, HIPS of the HIPS and SIPS stands for the Hydrographic Information Processing System, and SIPS is Sonar Imagery Processing System. The original concept was put together in 1990, together with the Canadian Hydrographic Service and the University of New Brunswick Ocean Mapping Group. The application has been in existence for over 20 years, and in that time has become the industry leader in post-processing of hydrographic data for multibeam, side scan, backscatter, single beam, and LiDAR. HIPS and SIPS has been designed to optimize processing productivity with tools such as area-based editing, the implementation of the cube algorithm, batch processing, and the ability to easily load peripheral data such as tide, sound velocity profiles, and even post-process navigation. Now looking at this slide here, you can also see we can import numerous sonar data formats, again ranging from multibeam all the way to LiDAR. Now again, once you bring in that data, you're actually able to create a surface very quickly in the workflow of HIPS and SIPS to kind of locate those errors very quickly and then edit them using our navigation editor, our attitude editor, swath editor, and subset editor. Now talking about subset editor, that's our area-based editor. Getting into more data cleaning, we can use IHO filters, statistics, or even cube. Now again in HIPS and SIPS we have a seamless and intuitive 3D visualization which will allow you to clean data in our 3D mode or even in our subset area-based editor mode. And again we have QC tools on top of all of that. Again, with all of this, we strive to help the industry achieve acquisition to processing ratios of better than 1-to-1. This productivity will reach even greater heights with the 64-bit version of HIPS and SIPS 7.1 that we're talking about today.
So that's right, Josh. HIPS and SIPS is now available in a 64-bit version. This means that HIPS and SIPS processors can now take advantage of all the RAM in a system and are no longer limited to just 3 gigabytes as was the case in version 7.0. This will mean that more data can be held in memory at any given time, reducing the input-output bottleneck.
Basically, Dan, what this means is that the native program execution will eliminate the additional translation layer to convert the 32-bit instructions to 64-bit. The result of this will be faster execution of the programs, meaning faster processing.
In a nutshell, I think what you're basically trying to say is that we're now able to utilize all the horsepower of our PC, giving us better processing. The only other thing that you forgot to mention was that in 7.1, we've also added support for Windows 7 64-bit. Now, Josh, we've just spent a couple of minutes talking about the new 64-bit version and the better processing, but I'm curious, just how faster processing are we actually talking about?
Well, Dan, I'm really glad that you asked. Some in-house testing that we've done shows that the merge process, as you can see here in this graph, is 30% faster with our new 7.1 64-bit compared to the 7.0 Service Pack 2 32-bit. Now, as well as the 30% faster merge process, the cube surface creation is now also 50% faster. Our HIPS and SIPS product manager, Corey Collins, has carried out some of his own testing using 13 days worth of data collected with a Simrad EM3002D in shallow water. This 13 days of data is equating to about 100 gigabytes of data, about 7.25 per day, or a total of 3 billion soundings, about 234 million per day as well.
So, Josh, I'm just looking at this graph here, and the results look pretty promising. So that red line there, that's HIPS and SIPS 7.0 in 32-bit, am I right in saying that the merge process for 100 gigabytes of data took over 9 hours?
We'll see that the 7.1 process was run in about 5.5 hours, meaning there's been a 4-hour improvement, again, between the 7.1 and the 7.0 Service Pack 2.
Well, Josh, I'm a hydrographic surveyor, and for us that get into data processing, that's bad news, because I used to enjoy hitting the merge button and going and putting my feet up for the rest of the day. But they are incredible results. In fact, we have a comment here that we received from one of our clients just earlier this week, Chris Freeman from Geodynamics in North Carolina in the USA, which is that's not too far from where you're from, is it, Josh?
Just a little north of South Carolina.
So what Chris let us know was that the 64-bit version is really saving us right now on a tight deliverable for some backscatter processing. We're loving it.
It's really good to hear some of this feedback from our customers. Another huge improvement to the 7.1 version is the CARIS file size, which is now 50% smaller in size due to new file compression techniques that we've come up with in-house. Now, along with the Caesar file size being 50% smaller, subset editor, or area-based editor, now allows for 3 times the number of soundings to be displayed.
That's some good area-based editing, Josh. Now, just in case any of you out there were wondering, these tests were carried out on the same data set, on the same computer, running the same operating system. The only variable was the version of HIPS and SIPS used, with the 64-bit version of 7.1 pitted up against the 32-bit version of 7.0 Service Pack 2.
I wonder who's going to win that fight.
7.1 all the way, my friend. Now, along with implementing the 64-bit operations in HIPS and SIPS, we've also updated the batch processor to allow for even faster importing and processing of data with just one click of a button.
For users that have used HIPS and SIPS in the past, the updates that have been applied to the new batch processor are in the back end, so the user will not see any difference. Now, in the previous versions, the batch processor would have reverted back into the HIPS and SIPS application to run the various tasks such as merge, tide, loading sound velocity profiles, and so forth. This is no longer necessary with the new batch engine, so the user is free to use the HIPS and SIPS for other processes. This will be leading to a central server being able to run the batch engine, distributing processes and tasks over other PCs on the network. Now, Dan, along with these improvements, I've heard there's some improvements to the cube layer. Is that true?
You heard right, my friend. We've added some real depth to the cube surface with the new shoal and deep layers. And excuse me for the bad pun there.
Dan, I can never excuse you for your bad puns.
You're not the first. So what we're going to do now is I'm actually going to open up HIPS and SIPS, and we're going to show you the new layers in the cube surface. So I've prepared a session that I'm going to open, and it's in Plymouth, which if any of you have done our HIPS and SIPS training course, I'm sure you'd have seen this training data set from Plymouth in the UK.
I definitely have.
Now, just for the benefit of any new users, so there's not much, and for the old users, there's not much difference in the interface for 7.1. Well, we've got a nice new icon here, but apart from that, it's still pretty much the same. So you can see over here on the left, we've still got our project window. So I've got my project, I've got my HDCS data structure, so I've got my vessel, I've got my days, I've got my lines. Here in the layers tab, I've got all the layers available to me. Here in the draw order, I can change the order in which things are displayed in the display window. I've got my output and selection window down the bottom, and over here on the right, I've got my properties window, which is highlighting the properties for whichever layer I have selected. So at the moment, I've got my rezone 50 centimeters, so this was data collected with a rezone 8125 echo sounder, and we've created this surface at 50 centimeter resolution. Now currently, I'm displaying my depth estimate. You can see on the left here that all of the usual layers that I have in my cube surface are still there. So I've got the density for my soundings, I've got the hypothesis count for the number of hypotheses at any given node, I've got my current depth estimate for the hypotheses, I've got the hypothesis strength giving me an indication of how good it is, and also I've got my new layers, so I've got shoal and I've got deep. So what I'm going to do, I'm going to zoom to a point in the surface here, and I'm going to turn off my depth layer and turn on my deep layer. By refreshing the view, you can now see that I've got an artifact, or I've got a feature available, or that I can see in my deep layer that I can't see in my depth layer. So here, using my tooltip, I can see that the sounding depth here, or the deepest sounding for this node, is about 9.74. Turning the depth layer back on, this is no longer visible, and I've got a depth of about 8.5 meters. This is true with other areas in the surface as well. By switching between the deep and the depth layer, I can see that I get other features. Now what I'm going to do is just a bit further to the north here, there's actually a little bit of there's some form of feature in this data set which may just be a rock or something like that. So as I'm looking, the sounding that I've got for this is about 7.52. What I'm going to do, I'm going to turn my shoal layer on to see if maybe this is shoaler than what's already being displayed. So you can see when I turn my shoal layer on, it's actually giving me about 7.46, indicating that maybe it's about 6 centimeters shoaler than initially thought. The other interesting thing to note here is the object is actually appearing larger now than what it did in the depth layer. So this is something that maybe could require further investigation to see what needs to go onto the chart. Another feature that I really like here is we've actually got the ability to turn on all of the layers at once. So I'll turn on the deep and the depth layer, and while only one displays, you'll see that with my tooltip, it's actually showing all three layers at once here. So I've got the value of my depth layer of 8.2 meters, which is my current depth estimate or hypothesis. I've got the deepest sounding for the node, which is 8.26, and I've also got the shoaler sounding for the node, which is 7.46. Now, Josh, I'm just looking over here in the properties window, and it looks to me like we've added an extra attribute name.
Well, you did very well to pick that one up, Dan. What we've got over here in the properties window is the platform name field, which is new to 7.1. Now, with this, it's adding the metadata for the surface. So the platform name is the vessel file that's been associated with this base surface here. This field, the platform name, will update as you add or remove lines from this base surface if new or if you add or remove a vessel by importing that line.
That's pretty intuitive, Josh, and it really just further adds to the already extensive level of metadata for surfaces created in HIPS. I mean, just as I'm looking over here, we've got the creation date that the data was created. We've got the data start and end date for the actual acquisition. We've got the creator, which well, look at that, Josh.
That was you.
It's me, and that's just to name a few.
Yes, Dan, this is really invaluable for companies' QA and Q procedures to go back and make sure that all the metadata is actually correct dealing with these surfaces. Now, another new feature in HIPS and SIPS 7.1 is the ability to compute a difference between the surfaces.
I'll believe it when I see it, Josh. Do you care to give us a demo?
I don't mind at all, Dan. So what we can do here is, using the same data set that Dan opened, all I'm going to do is now turn on the Kongsberg 3 meter. Here we go. I'll also select the deep layer. Then go up here to Overview. I'm going to zoom in to the part that we care about, which is the overlap. So now looking at this, I'm going to turn off the shoal and deep layer over on my left, refresh the screen, and then we can see that we have a nice overlap between these two surfaces. So again, the different surface is going to show us the differences between these two surfaces. So what we're going to do, is go up here to Processes, go down to Base Surface, and then do a different surface. Once you select different surface, what I'm going to do is select HIPS Demo, Kongsberg 3 meter, and the depth layer for the first, and then the Rezon 50 centimeter depth layer for the second. Then we need to put in an output surface name. I'm going to name it HIPS Demo, and just overwrite the one that I've already created. Yes, I do want to overwrite it, and then select OK. Once I select OK, it's actually going to start the creation process.
You know what, Josh? I'm going to have a guess that in HIPS and SIPS 64-bit, this isn't going to take too long.
Oh, look at that. 9 seconds, not long at all. All right, so now that we've got this loaded, what I'm going to do is turn off my other layers and then refresh. So now we can see that different surface right here. Now, what I'm going to do now that the surface is loaded, I'm going to go down and select the different surface, and then go up here and select Rainbow, and then go change this over to difference just so we can view this surface a little bit better. Now we can see some exaggerated color parts here, which is where there's more difference between the two surfaces. So if we zoom in, we can see that this blue area looks like it might be 5 up to 10 centimeters of difference. This green area is in the 20 centimeters. This yellow is in the 30, and this orange is in the 40, going up to the dark red, which is 50. So again, just looking at this, we can see that there is a lot of difference in some areas, while not any difference in others. Now, as a geologist, I might think that this might be some sedimentation that's occurred in this area. Dan, you've got more of a hydrographic background. What do you think some of these differences might be caused by?
Well, Josh, one of the first things I like to do when I've done a hydrographic survey is to run a comparison with the previous survey just to see how the two agree. So, I mean, what this can sometimes highlight is the area of red that we've got there. You know, maybe we've got something wrong with the tide if that's all associated with one line. It also could be showing some errors in our sound velocity data, or maybe there's just some bad soundings in one of the data sets. And it's actually a real advantage to be able to do this in HIPS, like in the processing package, because a lot of time you wouldn't be able to do this surface comparison until after. And by then you've already done all your exports and wasted a lot of time. The ability to be able to do this in your processing means it will highlight any errors straight away, so you can fix them before you've spent all the time exporting your products. Now, Josh, I've also heard through the corridors of CARIS that we've updated our display for DO bars and mosaics.
Absolutely right, Dan. What we've changed is we've made some improvements to our Caesar surface display. So as you zoom out, the display of the surface is generalized. So in previous versions, HIPS used the most intense pixel when determining which intensity value to display. In 7.1, an average is calculated between the highest and lowest intensity, and that is the value that's being used. This allows for better display of side scan data. As you can see over here on the left, in the older version, 7.0 Service Pack 2, we had these nice dark bands in between the geobars. And in the upper right-hand portion here, we can see it's very dark right next to very light portions. Well, over here in the 7.1, you can see that while we do have some smaller striping here, it's not as pronounced as the older version because of that calculation and doing the average between.
That's definitely pretty useful, Josh, and has definitely improved the display there. Now, here at CARIS, we've always strived to support as many sonar formats as possible in HIPS and SIPS. In the new release, we've added support for new data formats through our conversion wizard. Airborne Hydrography AB, otherwise known as AHAB, develops and maintains airborne laser systems for hydrographic and topographic surveys. One of their key products in their line is the Hawkeye 2 bathymetric survey system, which is capable of simultaneously collecting 4,000 bathymetric measurements with full waveform. We are now able to convert this data in HIPS and SIPS along with viewing the associated waveform information. Care for a demo, Josh?
That is amazing stuff, Dan, and no, I do not mind a demo at all. So here, let me go ahead and revert back to HIPS and SIPS here. What I'm going to do is first close this project. Now, after I close this project, instead of going straight and opening the Hawkeye data, I want to really kind of go over the conversion. So I'm going to select the conversion wizard here. Now, once we see the conversion wizard here in step 1, you can see that I've already selected Hawkeye. Now, then there's lots of other formats. So for all those newbies out there that haven't used HIPS and SIPS, you can see it starts at Atlas, and it goes down. We can see we have HiPAC, LADS, we have Rezon, we have Shoals, Simrad, SWAT Plus, and going down to XTF. Once we have Hawkeye selected, we can select Next, and then go to step 2 where we're going to select our raw data. So here I'm going to select the 2 bin folders, and you notice that one is TD and the other one's HD. So this is topographic data and hydrographic data. With those open, I'll select Next, and then go to Demo, and then I'm going to put them in my Hawkeye LiDAR project that I've already created. In step 4, we have the ability to kind of edit some of the data before it's ever brought in to HIPS and SIPS. So here, we can edit out any points that are outside of a navigation extent that we determine. Here I'm not going to do that, but I am actually going to filter out some of the depths. Because I know this data before I've done this demo, hopefully, I'm going to kind of cut out anything below 40 meters and anything above 50 meters. So with that checked, I'll then select Next and then select Convert.
The time is important, Josh, so to save time, let's just go to the data that we've already converted.
Exactly. So I'm going to select Cancel, and then go File, Open Session. Now, by opening this session, I've already created the project, I've already converted the files, I've already created base surface. Now that we've opened up the session here, we can see, kind of looking at the data, that over here towards the right that we have more topographic data. You can see possibly it looks like this might be a warehouse. We have some trees. Looks like this might be a road. These could be some houses through here. That definitely looks like a warehouse and some houses. As we move down, you can see that it looks like up there might be a river, and this definitely looks like a beach. Now, isn't this in your neck of the woods, Dan?
You're right, Josh. That's in Lakes Entrance, Victoria, which is only a few hours away from me. It's definitely a lot closer to home than what Fredericton in Canada is.
Definitely. You getting homesick there? Okay. Now, looking at this area particularly right here, a lot of the reason that our users, our clients, use Hawkeye or LADS or Shoals or any of the other systems that we support with LiDAR, it's because you want to look at the kind of the integration of water and land, where they meet. So the intercoastal zone management, looking at possible floodings, large tides, tsunamis, and so forth. So by being able to do this, you can easily make the correct models for that. So looking down here, you can see that we have more of the water data. And what I'm going to do is actually open up our subset editor to go over a new waveform viewer that we've optimized and brought into HIPS and SIPS. So now with this subset editor open, I'm going to load the data. And now for the new people that haven't used HIPS and SIPS before, you see we still have our display up here where I can zoom in. And then this yellow bar is controlling this 2D window here, which I can scroll up and down. And then over here on the right, we have the 3D window, where I can move this around to look at the different pieces of the data. Now, to actually open up the viewer, I'm going to go View, Toolbars, and go down to LiDAR. With the LiDAR bar open, I can select View Waveform, and then select some of the data. And you might have seen it if you're very quick there. I'll go ahead and open up that window that just popped up. And here we can see the waveform viewer that was provided to us by Ahab. Now here is where you can really kind of do some analysis of the data for the people, the users that really need to know this information, such as the infrared channel, the shallow channel, and the deep channel. Now again, with all this, you have some of the metadata that's associated with it, so you can properly analyze this. Now, as well as being able to look at the waveform viewer, you'll notice over here on the left, we have a LiDAR section in our subset tab in our control panel. Now, scrolling down here, you can see I have some property information, observed depths, process depths, process detections, observed detections, and going down, we actually have previous and next. So if I select a new part, and then come back over here and select next, it'll actually go to the next beam. So if I select OK, we can see we're at beam 113. If I select next again, we'll see where the old one was, where the old waveform, and you'll notice that we're now at 114. So now this is some pretty interesting stuff here, Dan. But what are some of the other formats that are now supported with 7.1?
Well, Josh, I'm just going to close down HIPS and SIPS here, and I'm going to go back to our PowerPoint. I don't want to save your session.
No.
So in addition to the Hawkeye LiDAR support, we've also added further support for R2 Sonic in data formats of XTF, HSX, EIVA, and PDS. We've also upgraded the Swath Plus converter to support the latest format, being revision 6E. The Rezon PDS converter has also been upgraded to support the latest revision of 1.006.
And by this slide right here, we can also see that the importing is not all that's been improved. 7.1 has also improved the ability to export data. With the new release, single beam data can now export both primary and secondary frequencies if available. This allows the user to utilize all the data that they collect in their export.
So going down there, Josh, I can also see that on the export, we have also added the ability to apply a vertical shift when exporting HIPS or a base surface to ASCII, which is useful if you've got a datum offset that you might need to apply to your survey.
Or if you'd like to possibly apply a time offset as well.
There you go. And our base surfaces can also be exported to an Esri grid, allowing, I guess, more users out there in the world to be able to open them. And with our geobars, we've also made it that you can send multiple geobars to export, so you're not restricted to just sending one at a time anymore.
Now, Dan, this is some of the improvements that's coming out with 7.1. Do you have any improvements here of something that's coming down further down the line?
Well, Josh, on the horizon, we have the Service Pack 1, so it's HIPS and SIPS 7.1.1, and that's scheduled for a release later this year, say around September.
Oh,
and
nice.
One of the biggest things that I'm excited about in this is our water column image processing that we're implementing. So
Ooh.
I know that there's some other people out there who are keen to see this as well. Do you care to give them a demo, Josh?
Yes, of course I can do this. What we'll do is have to go back and open up HIPS and SIPS. Now this time that I open up HIPS and SIPS, I'm going to be opening up the new Service Pack 1 of 7.1. So this is an alpha version that we have right now that Corey was able to give me. And so I could show this to you and what we've come up with so far. So what I'm going to do, now that HIPS and SIPS is open, is prove to you that it's the correct version. You can see 7.1, Service Pack 1.
You'd never lie, Josh.
And then I'll go File, Open Project. And then when demo, I'm going to open up the water column imaging data. Now again, this is only one line right now, but by selecting the line, I can now go into Swath Editor, which is our line-based editor. And with this open, now I'm just going to kind of resize my windows here, just so we can look at this a lot better. I'm going to bring my Properties tab down here. There we go. Move Swath Editor and water column up here to the top. Scroll this over. And now we can see both the water column across track and the water column along track. And you can see here on the left we have the plane view. Now, along with that, over here in the control window, we have the water column imaging tab. So with that selected, I can actually select reverse.
That looks much better, Josh.
I think it does too. And then, along with doing that to make it look better, we can actually change the max and min intensities. So what I'm going to do is kind of lower this down to kind of get rid of some of those noise. Get rid of some of that noise. That looks pretty good. I'll leave it at 45 for right now. Now we've got this the way that we're wanting to look at it, so we can best detect something that might be in the surface or be in the water column. I can actually select a beam over here, and we can see, one, the beam being shown and displayed here in the water column across track, and you can see where the beam is in the water column along track. So by scrolling up through here, oh, did you see that, Dan? I scroll back down, it looks like there's a blip in the water column.
Yep, I think you found a fish there, Josh.
Huh. Better finding it here than when I'm fishing. But yes, as you can see, you can scroll up and down the line to analyze what the water column looks like. Now this can be really helpful when you want to determine, is that sounding really erroneous, or was there some object there in the water column? Maybe it was a fish, or maybe it was a gas bubble, and this will help you determine that. Now as we scroll up, you can see we can see where we are in the water column along track, and see kind of what everything's looking like in the water column across track. Now as the ship takes this turn here, oh, it looks like, whoa, it looks definitely like a vertical wall right there.
Yeah, it's probably lucky the ship took that turn, Josh.
So we can easily see that, yes, there is something in the water column, and that was a wall. So as they go around the bend, you can see we can go down and we get away from that wall. Up, there might be another wall right there, I'm guessing, from that 90 degrees.
I've nearly hit the wall, Josh.
This is some really cool stuff that I'm hoping that a lot of our users are going to be excited about, because I'm definitely excited about finally seeing this in HIPS and SIPS.
And I think you're right, Josh. And what I'm going to do, I think, apart from the fact that that looks like an ultrasound, it is quite impressive.
It's your daughter!
So in addition to the water column image processing, in the next service pack, the 7.1, we're also going to be continuing and improving our integration of geocoder in our SIPS engine.
Wow, Dan, that really sounds like Service Pack 1 is going to make 7.1 even better. And hopefully we'll have another webinar to demo that. So looking even further down the track into the next year, what are some of the other enhancements that we expected to see?
Well, Josh, next year in HIPS and SIPS, we can probably in the next version, we can expect to see some nested grids or some variable resolution. So what you can see is we've been doing quite a bit of work here in-house on this. And here I've got a surface with two different resolutions. So here, around my features of interest, I've got quite a dense resolution to give me a lot of data capture. And as I'm getting out towards the edge of that, I've got a more variable resolution, or I guess a less dense, like a coarser resolution. But the important thing to note here is these two resolutions are all contained in one seamless surface.
And you can see by here at the bottom that we're also doing some updates to our subset editor to use the new 3D visualization engine.